Hello friends, today I am going to derive differential heat conduction equation in Cartesian coordinate system. Before deriving differential heat conduction equation, I have assumed two things. Firstly, that you know what is Fourier's law. What is Fourier's law? Fourier's law states that heat flux due to conduction in any direction is proportional to the gradient of temperature in that direction. I am saying it again. Fourier's law states that heat flux due to conduction in any direction is proportional to the gradient of temperature in that direction. Stated mathematically, we can write that heat flux, which is q dot by area, is equal to minus k dt by dx. Here the negative sign is introduced because heat flows in the direction of decreasing temperature. Secondly, we will assume that our material is isotropic. Our material is isotropic. Since this property is exhibited by most materials used in practice. By an isotropic material, we mean here a material in which thermal conductivity at any point is the same for all direction of heat flux. However, the conductivity may vary from point to point in the material. Now consider a differential volume dV in Cartesian coordinate system of dimension dx. This is x, this is y, this is z axis, of dimension dx, dy and dz. This is our differential volume. dV is equal to dx dy into dz. Now at x, heat conduction rate is q dot x. At x plus dx, heat conduction rate q dot x plus dx. Similarly, in y direction, heat conduction rate is q dot y. At y plus dy, it is q dot y plus dy. And similarly, we can write at z, heat conduction rate is qz, and at z plus dz, it is q dot z plus dz. We will assume that heat generation per volume in the material is E dot generation. So this is our differential volume and heat conduction rates and heat generation rate inside the differential volume. Now let us write Now let us write first law of thermodynamics for heat transfer. Heat transfer, which is energy coming in E dot in minus rate of energy going out plus rate of energy generation inside the element, which will be equal to rate of change of energy content of the material. Now what will be E dot in? E dot in is Q dot x, Q dot y and Q dot z. What will be E dot out? It will be Q dot x plus dx, Q dot y plus dy and Q dot z plus dz. And our energy generation rate per unit volume is E dot generation. Now let us put different terms in the equation. Our equation will become Q dot x minus Q dot x plus dx. I am writing only x component. Similarly, we can also write y components also, plus E dot generation, which is equal to E dot generation into dV, which is equal to dE element by dt. Now we will calculate first term, which is Q dot x minus Q dot x plus dx. By Fourier series, we know that this will be equal to minus dou of qx by dou of x into dx. From Fourier's law, qx is equal to minus k into area x into dou t by dou x into dx. What is our area AX? AX is equal to dy into dz. Now area AX can be constant as well as it can be variable. Right now I am assuming that it is variable. So our equation will become, I will multiply and divide the equation by AX, and the equation will become it will be plus 1 upon AX into dou by dou x of KAX dou t by dou x into AX into dx, which will become dV, which is our differential volume. Now E element, energy content of the element. Now what is the energy content of a material? Which is nothing but mass multiplied by heat capacity multiplied by temperature. Mass is equal to density into volume. Our volume is dV into C into T. T. In our equation, we will assume that rho density and C our heat capacity are constant. This is our assumption. Coming to our main equation, which was this equation. Now let us put the terms in the main equation. Our equation will become 1 upon Ax dou by dou x of K Ax dou T by dou x plus into dV plus E dot generation into dV equal to, I have assumed rho and C as constants, so rho dVc into dou T by dou T. Taking common dV from both the sides, it will cut out and our equation will become 1 by Ax dou by dou x Kax dou T by dou x plus E dot generation equal to rho C dou T by dou small t. So remember that I have assumed here that area Ax is variable and also area Ax can be constant. In case of plane wall, area Ax will be constant. Suppose our area is given like this. This is x direction and this is our area. Here in x direction, Ax is variable. Suppose Ax is equal to some b into x square or say b into x, like that. So it depends on what is given in the example or in the question. For the subsequent calculations, I will assume area Ax to be constant. So our equation will become dou by dou x of K dou T by dou x. Now I will also write y and z components also, plus dou by dou y of K dou T by dou y plus dou by dou z K dou T by dou z plus E dot generation, which is equal to rho C dou T by dou T. So this is our equation, differential heat conduction equation in Cartesian coordinate system in 3 dimensions. Here our temperature is a function of x, y, z and time t. If you know this equation in Cartesian coordinate system, then it is very easy to convert this equation into say cylindrical coordinates or say spherical coordinate system. I will show you how to write this equation in polar coordinates. Polar coordinates. So you have to remember 2 things. First, we have to replace x, y, z by r, phi and z. And second, you have to remember a transformation factor which is r by r 1 by r square comma 1 by 1. I will explain how to use this factor. First, we have to replace x, y, z in this equation by r, phi and z. And how to use this factor? Numerator will go inside the bracket and denominator will go outside the bracket and into the denominator. I will say it again. Numerator will go inside the bracket and denominator will stay outside the bracket. See, denominator r will stay outside the bracket. 1 by r, our denominator. We will replace x by r, dou by dou r, k. Now numerator will go inside the bracket, so into r, dou t by dou r, plus denominator will stay outside the bracket, 1 by r square, dou by, we will replace y by phi, dou by dou phi inside the bracket, k. Numerator will go inside the bracket which is 1, so dou t by dou phi plus z component will remain same, dou by dou z of k into dou t by dou z plus E generation equal to rho c dou t by dou t. So this is our differential heat conduction equation. Differential heat conduction equation in polar coordinates. Now we will derive differential heat conduction equation in spherical coordinates. Spherical coordinates. Let me paste the equation in Cartesian coordinate system. First, we will replace x, y, z with r, phi and theta. We will replace x, y, z by r, phi, theta. And second, we will use transformation factor which is r square by r square 1 upon r square sin square theta, comma sin theta upon r square sin theta. Remember this factor, you have to remember only this factor, and you can easily transform differential heat conduction equation in Cartesian coordinate system to spherical coordinate system. So write down, now we will write down differential heat conduction equation in spherical coordinates. Remember, replace x with r, we will replace y by phi and replace z by theta. In spherical coordinates also, numerator will go inside the bracket and denominator will stay outside the bracket. So first term, numerator will go inside, denominator r square which will stay outside. 1 by r square dou by dou r k into numerator is r square dou t by dou r plus 1 by r square sin square theta dou by dou phi, we replace y with phi. Inside the bracket k into 1, numerator is 1, k into 1 into dou t by dou phi plus what is in denominator, r square sin square theta, it will remain outside the bracket. 1 by r square sin theta dou by dou theta, we will replace z with theta. Inside the bracket k into what is in the numerator, sin theta into dou t by dou theta plus E generation is equal to rho c dou t by dou t. So this is our differential heat conduction equation in spherical coordinates. It is very easy. You just have to remember two steps: replace x, y, z with r, phi, theta and use transformation factor. And remember that whatever is in numerator will go inside the bracket and whatever is in denominator will stay outside the bracket. Very easy. Thank you.